I want to give some clarification on problem 1.5 part D, which is thionyl chloride. SOCl2, we're going to draw out the Lewis structure here, and I want to show you that there's two common resonance forms, well, two resonance forms possible, and I want us to also understand which one is more likely. And the answer that I gave you on the previous video is true. It's a correct answer, but it's also not favorable. So it's not an incorrect answer, it's just not the best answer. So I want to show you both of the resonance forms of this. Also, many questions have been asked about resonance. I want to make sure everybody's clear on it. So we're going to look at SOCl2, and I'm going to start designating and thinking about our central atom is going to be the sulfur. Sulfur can make more bonds, so it's going to be in the middle. The sulfur can have an expanded octet, and that's what I forgot to expand on when I was doing the previous explanation for this. So the sulfur goes in the middle, and then we're going to say it's going to have at least one bond to a chlorine, and then one bond to the other chlorine, and then we're going to have at least the one bond to the oxygen. When we added up our electrons, I should have done this first. We had sulfur is equal to 6, we have oxygen is equal to 6, and chlorine is equal to 7, but there's two chlorines, so that's a total of 14 plus 12 is 26 electrons that we're working with. Okay, now at this point we've used 6 electrons for the bonding, so we've got 20 left over. And we'll fill the octet on each of these: oxygen, chlorine, chlorine. So each of those has a completed octet at this point. Well, that takes away 6 by 6, 6, 6, and 6, and so that's going to take away just 18 more, and we're going to be left with 2 electrons. And I said in the video previously that this is good because sulfur only has 6 at this point, and sulfur needs 8. So we'll go ahead and we'll add those other 2 electrons in on the sulfur. This is a correct structure. It's not the best structure, and I'll explain why. So, looking at it, we need to realize that there's a charge associated, formal charge on each of these atoms. And we can go ahead and we can look at chlorine. Chlorine has a completed octet, and chlorine is exactly satisfied with one bond. So we know that the formal charge on each one of these is just going to be, a formal charge of chlorine is going to be 0 on each of those. Now, overall charge on the molecule is 0, but let's look at oxygen. Oxygen, of course, has we're going to look at the formal charge on oxygen. And oxygen brings in 6 valence electrons on its own, and we'll subtract from that the lone pair electrons, non-bonding electrons, and so we'll count up on oxygen. We have 6 of those. You'll see 1, 2, 3, 4, 5, 6. And then we'll also subtract 1/2 of the bonding electron number, and so we have 2 bonding electrons here, so we'll bring in 2. So the formal charge on oxygen is going to be -1, if I did my math right. Yeah, I'm pretty sure I did. So then sulfur, from the same approach, brings in 6 valence electrons. The number of non-bonding electrons is 2, and then we'll subtract that by 1/2 the number of bonding electrons, and we'll see we have 2, 4, 6. And so we'll get the sulfur has a charge of +1, because 6 minus 2 is 4, minus 3 is +1. So that gives us a formal charge on sulfur of +1, and oxygen has a formal charge of -1. And that's actually okay, but your more favored resonance structure is going to have the lowest possible formal charge on all of the atoms. So in this case, what will happen is a pair of electrons from the oxygen will get attracted over to this positive charge on the sulfur, and it will form a double bond. So we'll wind up with, let me drop through my numbers here. Oxygen will have now, instead of 6 unpaired, unbonded electrons, it will now have just 4 unbonded electrons. Sulfur still has a lone pair on it. And then chlorine over here will have its 6 lone pairs of electrons. So you see, formal charge does not change for chlorine. Now, what that gives us is oxygen is equal to, of course, 6 minus the non-bonded electrons, which is 4, minus 1/2 of the bonded electrons, which is 4 in this case because of the double bond. And so we'll wind up with a formal charge of 0. And sulfur, the same thing. 6 minus total of non-bonded electrons, 2, minus 1/2 the number of bonded electrons, which is 8 in this case. And so 6 minus 2 minus 4 is equal to 0. So that gives us a 0 formal charge on every atom. You say, well, hold on, wait. You know, hang on. Look at this sulfur. Now it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So sulfur has 10 electrons on the atom. Well, that 1, 2, 4, 6, 8, 10. Well, that is acceptable for sulfur because it's in the 3rd energy level down there. And it can have a expanded octet. What actually happens is some of the electrons wind up going into the d orbitals. But our structure is not going to be, looking at this, we may say, well, look, our structure is going to be trigonal planar because we've got, going in this direction. But see, this lone pair of electrons pushes it down, so it's actually a tetrahedral sort of shape to it. And just wanted to make sure the structure that you are aware that this structure is more likely to be found, but these are valid resonance structures of each other.